So, talking about predicting reactions, we need to start with remembering about the diatomic molecules. The diatomics are the ones that, when created on the sun, are so close to being a noble gas that they just jump in with the other thing created. So, hydrogen, another hydrogen, they're each one away, they bond with each other. Bromine, another bromine, they're each one away, they just bond with each other. So, these are the 7 elements that do this because once they're created, it makes a lot more sense for them just to bond with the other one right next to them than swim around the sun and try to find something else. So they spell the word Brinkelhoff, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, or they make the number 7 on the periodic table. But you got to remember hydrogen's one of them when you do the 7 thing. Okay, that's one thing. So the types of reactions we're dealing with, the first one is synthesis. Synthesis has the general format of A plus B goes to AB. So think about when you bake a cake, you have a whole lot of individual ingredients like eggs and flour, sugar, butter, vanilla, all that stuff. You put it together and you get one angry lamb, kids. So the point of this is you will always see the plus by itself on the reactant side. You're never going to see a plus on the product side. That's actually not even what I want to say. So you're going to see the plus only on the reactant side, not even by itself, only on the reactant side. I like that better. All right, it's not going to be on the product side. So when we're doing these things, you're going to just basically put together what's there. All right. You're going to do a two-step process. You're going to first determine the products, which is going to require you neutralizing charges, and then you're going to balance. So I know when we told you to balance, we told you don't mess with the subscripts, and that's still true when you balance. However, since the first step is not balancing, you're neutralizing charges, you can mess with subscripts. So step one is determine the products. So here, when magnesium gets together with chlorine, magnesium has a +2 charge on the periodic table. Remember this? So magnesium has a +2 charge. It's in the +2 region. And because of that, when it gets together with chlorine, which has a -1 charge, right? -1 charge. Wait. In order to neutralize my charges, I need 2 chlorines so that my sum is 0. So that gives me MgCl2. Then you balance. So once you get your neutralized charge product figured out, then you can start doing the balancing. This one doesn't require balancing because there's 2 chlorines and 1 magnesium. Magnesium with oxygen, magnesium is still +2. Oxygen, you may recall, is -2. So because oxygen is -2, that means they're neutralized as 1 and 1. But for balancing purposes, since we had 2 oxygens and only 1 magnesium, we want to put a 2 here, and then that would require a 2 in there as well. Potassium and sulfur. Potassium is +1. Sulfur is -2. So when potassium gets together with sulfur, the first thing we want to do is combine charges. Potassium's +1, sulfur's -2, and we want to make sure we're neutralizing it. So +1 plus 1 minus 2 gives us a 0. So we need 2 Ks for every S. And then we balance. All right. So you can mess with the subscripts when you're determining products. You cannot mess with the subscripts when you're balancing. So aluminum and oxygen, aluminum is +3 and oxygen is -2. If you forget aluminum is +3, it's right here. It's always +3. All right, so we got aluminum +3 and oxygen +2. For this to neutralize the charges, we got to go to the lowest common factor of 6. Oops. That's what happens when you start thinking about sixes. All right. Then that'll equal 0. So I need 3 oxygens and 2 aluminums. And then I can start balancing based on my product that I've put together with neutralized charges. So when this gets together, we need 2 of these and 4 of those and 3 of those. All right. But here's the thing. How do I know you can do that? When I Google, watch me Google, kids. Watch me nay nay. Aluminum oxide, right? Al2O3 is what it is. That's what it is. Look, I can even make a cool circle. Al2O3 is what it is. There's no turning around from that. That's what aluminum and oxygen do when they get together. So that's why you have to do the subscripts there while you're neutralizing the charge. All right, decomposition has one reactant. So there's one thing like a log decomposing into many things. Okay, so you're going to see your plus only on the product side. All right, so your plus is only going to be on the product side since you're only going to have one thing falling apart, one squirrel decomposing. So when we're doing this, the same thing applies. Well, these are easy when they're binary. So when there's only 2 elements, it's very easy. You just do what it was on the periodic table. Hydrogen and oxygen is what peroxide decomposes to. Sodium and chlorine, but chlorine is a diatomic. Oxygen is a diatomic. Hydrogen is a diatomic. Mercury is not a diatomic, but oxygen is. So that's all you do there. Okay, so like I said, you got to remember your diatomics. And then it gets trickier when we start doing more than 2 elements. So decomposition with 2 elements, it's just whatever it was on the periodic table, with the exception of you need to remember about your diatomics. Okay. With decomposition of greater than 2 elements, they fall into like 5 categories: carbonates, hydrogen carbonates, hydroxides, and chlorates. Actually, only 4. Only 4 categories. All right. So the carbonates have a -2 charge. They always fall apart into some metal oxide and carbon dioxide. So whenever you see a reaction that has just the carbonate, you're always going to make CO2 as a product. And then you're going to put the metal, which in this case is the calcium, with oxygen. But you need to balance your balance. You need to neutralize your charges. Calcium is +2. It's right here, +2. Oxygen's always -2. I think you're getting that now. So if that's +2 and oxygen's -2, it only takes one of each to equal 0. So again, if you Google calcium oxide, what you get is CaO. We're not making anything up here, right? CaO, that's what it is. So that's why we can quote unquote mess with subscripts. We're not making this up. This is just acknowledging what exists. Sodium with oxygen, because sodium is a +1 here, it needs to do 2 with the oxygen. So sodium is +1, oxygen is -2. For that to be neutralized, you need 2 sodiums. Then you balance. After you've established the products, then you balance. And when you're balancing, you can't mess with subscripts anymore. So calcium carbonate, there's 1 calcium, there's 3 oxygens, that one's done. There's 2 sodiums, there's 3 oxygens, there's 1 carbon, that one's done. So the good news is I was told we'll probably take it easy on the balancing because of the predicting. So the only difference between this and this is that this carbonate does not have a hydrogen with it, and this carbonate does have a hydrogen with it. It's hydrogen carbonate. So because of that hydrogen, we include water as one of our things. So remember when you're determining products, you have to you have to neutralize charges. Sodium, recall, is the +1, right? It's right here. Maybe I should get out of there and delete all these. Wow, it's every single time I do them. All right, so sodium is +1. Sodium's +1. It's supposed to get together with carbonate. Carbonate, as we just learned here, is -2. So carbonate is -2. So it should make sense. We need 2 sodiums with that carbonate. So that's going to make Na2CO3, plus it's also always going to make carbon dioxide and water. So this one's going to make carbon dioxide and water, plus the magnesium, which on our chart here is +2, next to sodium. Our magnesium is going to be balanced perfectly with carbonate by just having one of each, because if magnesium's +2 and carbonate is -2, they equal 0 already. All right, so then you balance. Now we balance after we've established the products. So magnesium carbonate, there's one magnesium, there's one carbonate, there's 3. I think that works. Yeah. And this one, I think, well, nope, we at least need 2 of these. So we at least need 2 of these so that there's 2 sodiums. There's now 2 carbons. 3 times 2, 6 oxygens. Yeah, so that all works. Ignore this. That's for something else. All right. So hydroxide has a charge of -1. All right, it has a -1 charge. HCO3 has a -1 charge. Carbonate has a -2 charge. Hydroxide's a -1 charge. Metal is going to get together with oxygen. So when we put this metal calcium together, or it decomposes with as a hydroxide, the calcium is going to end up with oxygen and we're going to make water. So the question is, what's the formula for calcium oxide? Well, you can literally look it up, because you're going to find that calcium oxide is CaO. Oh, I already did it. It's CaO. All right. So that's why it's CaO. But if we look at charges, calcium is +2, oxygen is -2. So that's why it's a 1-to-1 calcium oxide. So now that we've done this, now we can balance. And with balancing, we can't mess with subscripts. So there's 1 calcium, there's 2 hydrogens, and there's 2 oxygens. So it's done. All right. Sodium hydroxide is going to become sodium oxide plus water. Sodium has a charge of +1 and oxygen is -2. So we're going to need 2 sodiums. Sodium is still +1. So sodium is +1 and oxygen is -2. We're going to need 2 of those. Now we can balance. We have 2 NaOH, 2 NAs, 1 oxygen. Oh, no, 2 oxygens, 2 oxygens, and 2 hydrogens. Yeah, so that's balanced already too. All right, the last one is the chlorates. So again, remember, determine the products and neutralize charges. So the charges, or the products for every chlorate, is going to be the metal with the chlorine, and then O2. So potassium is in group 1, is -1. So chlorine is -1, potassium's +1, so 1-to-1 is fine. The fact that we have 2 of these, so we need 2 of those, and that gives us 3 O2s. Oxygen is a diatomic, so it's O2. So anytime you have a chlorate, it's going to make O2, and it's going to make the metal with chlorine. Now for Mg, that's a +2 charge. Chlorine is still a -1, right? So Mg is still a +2. So MgCl2 is what that's going to turn out to be. Neutralizing our charge, it's MgCl2. Now that all the charges are established, all the products are determined, now we can do the balancing. We got 2 of those, and we got 3 oxygens. So that's sort of the skinny on this. Let's do a hard one. Let's do iron 3 chlorate. So chlorate has a -1 charge. ClO3 is a -1 charge. That's a polyatomic anion. So if that's going to fall apart, that iron 3 needs to get together with the chlorine, and we're going to make oxygen. Well, iron 3 is iron 3 plus, and we know that because there are 3 chlorates. So that's going to need 3 chlorines to neutralize it. And so that's why there's 3 chlorines, there's 1 iron, that works. And then the chlorates, 3 is 9. Ugh, it's going to be ugly, kids. So 9 oxygens, and since they're going in pairs, that's not going to be possible. So it's 9 halves, and then we multiply everything by 2. So it'll be 2 of these, 2 of those, and 9 of those. Thanks, science. All right. That's all I got to say.